Okay, guys, we are going to start the topic for merge sorting. And thank you once again. This is Niket Jaswal, and today we are going to talk about merge sorting. Like, before I start my understanding, oh, one second. I think I have some problem. Uh, okay, neither ways. Let me first try to understand and make sure what is merge sorting. So, merge sorting is the estimated time analysis for this merge sorting is n log n. That is for the worst case. So, like, and we will talk about more about this time analysis in more and more lectures, more and more sorting algorithms we are going to get. But today, my focus is on merge sorting. Like, if I have given an array of input of 2, 4, 1, 6, 8, 5, 3, 7, I need to sort my array into ascending order, so give an output as 1, 2, 3, 4, 5, 6, 7, 8. Okay, so in order to start with this algorithm, so I will say there's something called n1 and n2, which is denoting the length of the array. Okay, so my I would be starting from 1 to n1 and the other will start from 1 to n2. So how this n1 and n2 is calculated? Like n1 and n2 is calculated saying by taking into assumption saying that my first four elements are n1 and the other four elements are n2. I will split this so it will give 2, 4, 1, 6. The other half would be 8, 5, 3, and 7. So I need to recursively do this process till I reach the leaves. The leaves is the very last element. So my merge sort algorithm will work with one if condition if the entire length I'm saying is k, okay, and which is starting from this to this, if k from starting position of my array to the ending position of my array. So if k is less than 2, it will means the length is less than 2. It means 1. If it is 1, so we reach the leaf. So no more recursive sorting algorithm, not sorting, merge sorting is required. We are finished, just return it, come out of the loop, and we are done. Now, for the other half, for this particular half, we are we are talking about. Let me first minimize this. Okay, not minimize like putting into halfway. I'm sorry about that. So now, when we are going to start working with, when we have reached the elements, now we have to again do the ascending order. Repeatedly, we have to follow this till again we have not reached the half element. Okay, we got that right. So I equals to 1, then I equals to 2, then I is 3, then I is 4. Same that j is 1, j is 2, j is 3, j is 4. So we will sort this then 2 and 4, then it will go back, it will be 2 and 4 because it is in ascending order. Now this 1 and 6, it will go up, it will have 1 and 6. Now again, this is my left side, this is my right side. Now this is my, when I am going to check if L of I, now I is, so I'm again going to repeat this process like normal. Again I is 1, J is 1, okay. So L of I is 2 less than 1, no. So it is S part. So my A of K, not like this element. Now, because I am going to fill this, right? I need to fill this part. So now my first element is 1. So when this is 1, my J has increased to from 1 to 2. Now this is 6. Now this is 2. Is 2 less than 6? Yes. Now this is my 2. So now I has increased to from 1 to 2 and J is 2. So now 4 and 6. So yes, my left hand side is greater than less than the right hand side. So yes, my third element would be 4 and 6. Same thing it will go for the right hand side. It will first split up into two parts from 4 to 2, then 2 to 1, and we have reached the very last element of my our leaf. So we are good to go. Stop it and then calculate the entire branch. So again it will have 3, 5, 8, 7 in the same logic. Now when we are going to put it back, we have to again check this condition again. And what this condition says, if left hand I 1, right hand side 3, is 1 less than 3? Yes, so I is 1. So I will increase from 1 to 2. Now I is 2. Is 2 less than 3? Yes. Now this is 2. Now I has increased from 2 to 3. J is still 1, right? So J, now 4. Now 4 is less than 3? No. Go to the else part. Now J has become 2. So now I is 2, J, I is 3, J is 2. So now 4 is less than 5? Yes. Now I would be 4. Now J would be 2. So 1, 2, 3, 4. So now 6 less than 5? No. Now J would be 2. Correct? From 1 to 2. Now J would be, now the 5 is inserted. Now I is 3 and J is, I is 3 and J is now, I is 4, sorry, and J is now 3. So when I is now 6 less than 8, yes, now 6 will go over here. Now it will check 3, 5, 7, 8. Now this is, I think I did something wrong. 7 will go over here and 8 will go over there. I'm sorry about that. So it's 3, 5, 7, 8. So now when these two are there, then it will just check it and it will insert 7 and then it will insert 8. This is the part of the algorithm. Now when I will study the runtime analysis. So my runtime analysis says merge sort of x1, x2, x3, which is recursively it is happening. If as soon as I reach the very first element, which we talk about in this slide, and this is my first element 2, when it is sorted will be 1, right? When you are in the very first element, you just come out of the loop, and the constant time denotes big O of 1. Okay. Otherwise, it is recursively we have to follow this. That is merge sort of x1 of the first half to merge sort of second half first half plus 1. The first half plus 1, it mathematically was 8, right? 8 divided by 4 is 8 divided by 2 is 4. So I will go from 5 to the last element. And this time, for this method, this time it takes tn by 2, and the other half it takes tn by 2. So my total time, or my running time to run the above algorithm would be 2 times this plus c of n. The c of n is some constant, which some constant time when it takes to merge the two particular array. Okay, so this is t of n times 2. So my equation will of now turning time would be now 2 times of n by 2 plus c of n. Now how I am going to generalize, how I'm going to generalize my running time. So my running time would be t of n of 2 times this. First I'm going to minimize this part. I will expand this. My t of n is 2 times t of n by 2 plus some constant time. This is runtime of a method. And this is the breaking down into two halves. The total time for breaking down into two subproblems, right? Or not, I will say two, maybe more. So when you will say when this is the general term now for n equals to n by 2. So this would be n by 2. 2 times into t. Now this n by 2 will change to n by 4. C times n by 2. We have evaluated right now how we are going to calculate the t of n for n by 2, right? So we are evaluating the time for n by 2 interval. Now this particular expression, right? Which expression? This t of n is 2 times t of n by 2 plus some constant value. Now this particular t of n by 2, right? This t of n by 2 is this. Now this particular part will have this value, and it will fit into this particular part. So this 2 times t n by 2 times t of n by 2 plus c of n by 2. It will go over here. So when we multiply this, 2 into 2 will be 4 times t n by 4 plus this 2 into this 2 will be cancelled, and it will be just c of n, so it becomes 2 times cn. Now same thing. Now this has become 4t n by 4 plus 2 of cn. Now when we want to calculate n by 4, right? So to calculate n by 4, we will have to give the value 2 times t of n by 8 plus c times n by 4. Now to how to calculate t of n, we just need to pass the value for n by 4. This is t n by 4. Now this value would be 2 times of this plus 2 times of cn, right? You're getting this? So now when you will see there is a general term coming, right? When it was n, it was 2, then x to the power x n by 2, right? Then there's some constant value k over here. So when n was n by 2, it was 2 over here. Then it has changed from 2 to the power of 1 to 2 to the power of 2. Then still it is. So when we calculate it for n by, when we calculate the t of n, it has changed now to 4 t times n by 4 plus 2 times c of n. Similarly, when it is n by 4, the t of n is 8 times t. So this is 2 to the power, this is 2 to the power of 2, this is 2 to the power of 3, right? And this is some constant value k, that is 2 to the power of k. So we can represent t of n as the running time analysis as 2 to the power of k into t times n by 2 to the power of k. This is 2 to the power 3, then this is 2 to the power of 2, this is 2 to the power of 1. And there is some constant value k, that is 3, then 2, that is kcn. So the most generalized term would be for t of n for the merge sorting would be 2 to the power of k, to the power of k into t of n divided by 2 to the power of k, right? 2 to the power of k close bracket plus a into some constant. This is the most generalized term. And that's all for today. And I will just add my hyperlink so that you can refer to my tutorials. Thank you so much and have a great day. Bye bye.